Alright, so I'm going to work through this example right here of section 1, functions and models. So our example is asking us to find the domain of g of x. So our function g of x we're given is equal to root of x plus 6 divided by x squared minus 2x minus 8. Okay, so in order to find our domain, we have to find the restrictions of each function. So on the top, we have a square root function. So the general parent form of a square root function, parent form is just a fancy word for the simplest form of this equation would be y is equal to root of x. Okay, so root of 0 is 0. Root of 1 is 1, and then root of 3, you can't do that because no number times itself is going to give you a 3. And then root of 4 you can do because 2 times itself is going to give you 4. So root of 4 is equal to 2, and you would go down the list. So again, no two numbers are going to give you 5 or 6 or 7 or 8, but 3 times 3 gives you 9, so root of 9 is equal to 3. And if we plot this function on a graph, it's going to look something like this: 0, 0, 1, 1, 4, 2, and so on. So what are the restrictions on this graph? Well, it has to be greater than or equal to 0, because we can never have a negative in a square root. So y is equal to square root of -1 is not possible, or -2 is not possible, because no two number times itself is going to give you a negative number. Because what if we had, let's say, root of -4, you'd think, I don't know, -2 times -2, well, that's going to give you +4. So it's not possible to have a root of a negative number. So this is what that graph is going to look like. And our restriction is that it has to be positive. So now that we know it has to be positive, we're going to set our numerator, that root function, x plus 6 is greater than or equal to 0. So to undo a square root, you square the function, so to the exponent of 2. Those cancel, and 0 squared is just 0, so greater than or equal to 0. X plus 6 is greater than or equal to 0, minus 6 x is greater than or equal to -6. That is our first domain restriction. So on the bottom here, we have a polynomial. So the general rule for polynomials is whenever you have a polynomial, your function is going to be existing for all real numbers. But in this situation, since our polynomial is on the denominator, we do have a restriction, because let's just placehold this square root function 1 for now. X squared minus 2x minus 8. Are there any restrictions here? Yes. This cannot be equal to this. So x squared can minus 2x minus 8 under no circumstances can give you a 0, because what is 1 divided by 0? Well, it blows up to infinity, because 1 divided by very little amount of parts is going to give you a super big number, and that's just not possible for us. So general rule of thumb to remember is you can never have a 0 in that denominator. It's not okay. So x squared minus 2x minus 8 has to be greater than 0. So it's not inclusive like our previous function where it was greater than or equal to 0 for that numerator. For this instance, under no circumstances can this equal 0. So how can we figure out where it's going to give us that 0? Well, we can factor this polynomial. And how do we factor it? Well, we have to find two numbers that multiply to -8 and add to -2. So I would list the different factors of 8, which is 8 and 1, 4 and 2. So I can see, well, 4 and 2 makes the most sense. And then you have to figure out the relative signs. Well, we have a -8 and a -2, so that tells me that -4 and positive 2, so x minus 4, x plus 2, x minus 4 is greater than 0, so plus 4, x is greater than 4, and x plus 2 is greater than 0, minus 2, x is greater than negative 2. Okay, now we're going to put all our restrictions over here. So now we know everything. We have this x is greater than equal to negative 6, x is greater than 4, x is greater than negative 2. So our domain is going to be from negative 6 to negative 2 union, oh shoot, I don't have enough space there. So it's going to be negative 6 to negative 2 union, negative 2 to 4 union, 4 to infinity. So again, closed bracket means inclusive versus our parentheses means not inclusive. So since this is greater than or equal to 6, this tells me it's a closed bracket around that 6. Since this is only greater than 4, that's going to tell me parentheses, and that's going to tell me parentheses. Well, you might be asking, why is it negative infinity to negative 6, negative 6 to negative 2? Well, again, because you can never have a negative for that square root function. It's always going to be greater than 0. So you always have to look at the type of graph you're dealing with, the type of equation you're dealing with, where it's relative to the equation. I mean, what I'm trying to say here is like this was in the denominator, so you have to think about the position of where your function is and the restrictions in the certain graph. So that's how you solve that problem.